Hello everyone, I hope you're having a good day, and we are going to begin our Module 15 lessons. And before watching this video, you should have watched the real world video connecting to Module 15. And here we are on day 1, and we are going to be looking at defining and evaluating a logarithmic function. And this is day 1, so we're going to be just looking at the basics of logarithm. So we're going to be learning about finding inverse of the exponential function. So speaking of that, we know that exponential functions and logarithms are inverse each other, just like x squared and square root of x are inverses of each other. So we are already very familiar with exponential functions because we have spent the entire module 13 and 14 learning about exponential functions. So we're going to take a look at the inverse of the exponential functions, which is the logarithm function. And here we have the logarithm function connecting to exponential. So if we again take a look at the exponential function, take a look at 2 to the x, we know the inverse of the exponential is going to involve the logarithm base of 2. So it's very important you take a look that the base is going to stay in the base. So this exponential function has a base of 2, and the logarithm that is opposite or the inverse of it is going to have the base of 2. And so we read this function as the logarithm with base of 2 of x, or log base 2 of x. And it accepts the power of 2 as input and delivers the corresponding exponents as output. So let's take a look at a graphic representation of the two inverse functions. And actually, going back before we do that, let me just also mention that we have many different functions that are exponentials that have the logarithm inverse. So for example, y equals 3 to the x, the inverse of that is going to be y equals log base of 3 of x. Same thing with y equals 10 to the x, the inverse of that is going to be y equals log of x, and without anything, it's just 10, base of 10. So we can say log of x or log base 10 of x. So either one of them. So these are just some examples. There's many more functions that are exponential, and the inverse is the logarithm. So let's take a look at the graph again. And so here we have y equals 2 to the x, and 2 to the x is an exponential function. So here we have a table showing the values that make up the exponential function, which is over here. And on the right hand side, we have the logarithm function, that is log base of 2 of x. And the graph is this one right here. So if you look at it, this 2, and that actually makes sense because the two functions are inverses of each other, and they're reflected through the line y equals x. So we can see that they are inverses of each other. And as you can see that for graphing for the exponential function, we enter the values into x and we look for the y. But here for the logarithm function, it is based on the values of y. So we're going to go into graphing later on, but right now we're just taking a look at how the two functions look like as inverses on a graph. So let's take a look at some characteristics of both functions. So on the left side, we have y equals 2 to the x, which is an exponential function. And the domain, let's do a review because we're already familiar with the exponential function. The domain for all exponential function is all real. Since it goes left and right, it does not stop. So we have all reals. And the range, as you can see, is above the x-axis. So y is actually greater than 0. That would be the range. The y-intercept, we know that anything to the 0 is 1. So all exponential functions right here will have the the parent function, will have the y-intercept of 1. So it is 0, 1. And end behavior, as you approach the left side of the graph, you will notice that the graph is slowly approaching 0. But it does not cross the line, so it approaches 0. As you go to the right-hand side, the graph goes up to infinity, all the way up, so it approaches to the infinity. So on the right side, it approaches infinity. But let's take a look at the logarithm function. Domain, you notice that the x value actually stops here on this y-intercept, so it does not cross the y-axis. It does not cross the y-axis. So then we know that value only goes to the right-hand side, because we cannot actually take the logarithm of any negative number. So the negative values do not exist. Right here, you take a look at this list. Everything is positive, so we cannot take negative logarithm. So the domain becomes x greater than 0. And you also cannot take the logarithm of 0. So the range, on the other hand, the graph can go up and down. So it goes all the way here and it goes all the way up. So it is actually Oreos. So if you take a look at this point at the two functions, the exponential and the logarithm, that these two are inverses of each other. So that actually would make sense that the domain of one becomes the range of the other one. So the domain of the exponential becomes the range of the logarithm, and the range is the domain of each other as well. So that would actually make a lot of sense. Now we have x-intercept instead of y-intercept. So notice that the x-intercept here is 1, 0. So here we have, because the logarithm of anything 1 is equal to 0, because like the exponential, anything to the 0 power is 1. So here we have anything to the 0 logarithm also is 1. So the logarithm of 1 is equal to 0. So we have 1, 0 as the x-intercept. And behavior, as x approaches 0, then as x approach 0, the y value approaches the negative infinity, because as you go to the left side, it goes down to negative infinity. And as x goes to the right-hand side, y value approaches positive infinity. So those are the characteristics of the two inverse functions here. You can take a good look again and make sure that you understand the difference between the two. Now let's talk about excuse me, converting between exponential and logarithmic forms of equations. So I think a lot of people do not feel comfortable just reading or working with logarithm, but it helps a lot when we rewrite logarithm in exponential form. So let's take a look at the left side. We have the exponential form. Anything the base to the any power x equals a. And this form translated to logarithm looks like this. The log of base b, notice the base stays as a base. Base b of a equals x. So let me use a set of arrows to help you understand this. So base b raised to the x power is equal to a. And that's how you would write a logarithm function without using log. And so we read it as the base b of the exponent becomes the base of the logarithm, and we read it as b to the x equals a, and that is the exponential form of the logarithm function. So today we're only going to be practicing writing basic logarithm forms in exponential. So let's practice writing the first problem. So we're going to write the exponential equation. So we need to learn to translate between exponential and logarithm. So right now, obviously, it is an exponential form because there is no log. So to write this in logarithm form, we're going to use the method that we showed you on top using the log. So we're going to start with the word log. And we know that base is going to stay in the base. So we know here base is 2. And 6 is the exponent. So the exponent is going to go onto the right. And so if we follow the arrow, so just follow the arrow and you know how to write it. So 2 to the 6 equals 64. And that's how you would write this. So again, if you just follow the arrow, this would be log base of 3 because we can see that the base is 3. And the power is going to go on the right hand side, so -4. And then the answer is going to go right here. So if you follow the arrow, 3 to the -4 equals 1 over 81. That would be the way that you write this. And now let's go ahead and pause the video so you could try these two problems. So make sure you try it before you look at the answer. And now that you've had a chance to try it, let's rewrite these two exponential as logarithms. So the base is 2, and we know the power goes to the right-hand side. So 2 to the 4th power equals 16. And the same thing over here, log base of 4, and we have 4, the power is -3, so 4 to the -3 equals 1 over 64. And example 2, let's take a look. Write each logarithm equation in exponential form. So we're going to go the other way. And this one is actually easier because it's already got the log form and you just need to follow the arrow. So it's going to be 10 to the 2nd equals 100. And 5 to the 3rd equals 125. And let's go ahead and have you try a couple problems. So make sure you pause the video and try these problems before you look at the answer. And let's take a look. Again, you raise 2 to the 7th power equals 128. And 100 to the 3rd power equals 1 million. Okay, and that's how you write the logarithm back to exponential form. And that's a wrap for this lesson today. Your assignment is to do the book set, get started with your HIW, and copy notes for day 2 of 15.1. Have a nice day.